We are shown here the representation of an atom of a certain element. These red circles are representing the protons, these yellow circles are representing the neutron, and these blue circles which are rotating about the center are representing the electron. This picture in no way is to scale. The nucleus, which contains these protons and neutrons, is actually very tiny compared to the size of the entire atom. But for this problem, just so that we can count how many protons and neutrons there are, we have drawn these in this way. Alright, so we have to find the element symbol for this element, the mass number A and the atomic number Z. Remember, the atomic number is represented by Z and the mass number by A. I always used to get confused. I used to write atomic number A. But no, the mass number is A. And these letters are coming from the German words for mass number and atomic number. But we won't get into that in this video. So let us start with the atomic number Z. The atomic number Z is basically the number of protons in the atom. How many protons? So if we count protons, which are the red circles, 1, 2, 3 and 4. So the atomic number of this element is 4. That's it. Next, let's find the mass number. The mass number is the number of protons plus the number of neutrons. Because these are the elementary particles that contain mass. Electrons, if you remember, have negligible mass as compared to a proton and a neutron. These are the heavy bits of an atom. So for the mass number, we add the number of protons and the number of neutrons. So here we have 4 protons, which we already counted, and 1, 2, 3, 4, 5. 5 neutrons. So 4 protons and 5 neutrons, this gives us 9. So the mass number for this atom is 9 and the atomic number is 4. Finally, we also need to find the element symbol. So to represent an element, we represent it like this. We write the chemical symbol, let's call it X for now, the mass number A on the upper left side and the atomic number Z on the lower left side. This is how we represent the symbol of any element. Here the atomic number is 4. If we look at our periodic table, the fourth element, the element which has an atomic number of 4 is hydrogen, helium, lithium, beryllium. So here the X will be represented by Be. This is the chemical symbol for beryllium. Then we have the mass number A, which we counted, it is 9, and the atomic number Z, which we also counted, which is 4. My 9 was looking like a 4 there, but okay. This is the element symbol for this atom. Alright, so if we have understood this, let's try and do another problem, which is just the reverse of this one. Here it is. We have to find the number of protons, electrons and neutrons in a neutral atom of 7734 selenium. So this is the atom. Right now we are given the element symbol and we have to find the number of protons, electrons and neutrons in a neutral atom of this element. Okay, let's see. Alright, so in general, our element symbol will have the chemical symbol, which here is selenium, and they will have the mass number on the upper left side and the atomic number on the lower left side. So here this means that the mass number A for this atom is going to be 77. This is the number of protons plus the number of neutrons, because these are the heavy bits of an atom, remember? And we are also given Z. Z, which is the atomic number here, is 34. Lower left side we have 34. And this is the number of proton. This is what atomic number means. Atomic number is the number of protons. So we already have the first number that we wanted, the number of protons. So the first part will have an answer of 34. Next we need to find the number of electrons. We see that we are given that the atom is neutral. Neutral atom will contain equal number of protons and electrons. So the number of electrons will also be 34. If we were given, for example, that the atom had a charge of -1, then we would know that there is one more electron than there are number of protons. In that case, the answer would have become 35. But here, since the charge is 0, since it is a neutral atom, therefore number of protons and electrons are equal, and we have 34 electrons and 34 protons. Finally, we also need to find the number of neutrons. Before I do this, pause this video and see if you can figure it out. Alright, I hope you have tried this. We already know that the number of protons is 34 and the number of protons plus the number of neutrons is 77. These two together can give me the number of neutrons. So we have 77 equals the number of protons, which we know is 34, plus the number of neutrons, that is what we want. So the number of neutrons is 77 minus 34, which equals 7 minus 4 is 3 and 7 minus 3 is 4, 43. So we have 43 neutrons. So in this way, we can go the other way around as well. Using the element symbol, we can find the atomic number and the mass number. Finally, in this video, I also want to talk to you about isotopes. If you look at carbon, there are three types of atoms of carbon: 12C6, 13C6 and 14C6. All of these have the same number of protons. They have the same atomic number, but they have different mass numbers. These type of atoms which have the same atomic number but different mass numbers, these are called isotopes. Many elements have different isotopes. Even hydrogen, the first element, has three isotopes: 1H1, 2H1 and 3H1. All of these have the same atomic number 1, but they have different mass numbers 1, 2 and 3. And if you have paid attention so far, you will see that isotopes, because they have the same atomic number, they have the same number of protons, but they will have different numbers of neutrons, because only then they can have different mass numbers. The protons are the same, that is why the atomic numbers are the same, but because they have different number of neutrons, they will have different mass numbers. So remember this term, isotopes. It's going to come in very handy in the rest of your chemistry journey.